The development of optical fiber has enabled a revolution in modern telecommunications. In the 35 years since optical fiber was first suggested, the effective speed at which information can be transmitted has increased from kilohertz rates to terabits per second using optical multiplexing. Along with increased transmission speeds comes the requirement to more completely test the optical medium through which the signals are passed. To verify that fibers are able to transmit light reliably, a variety of commercial instruments have been developed for certification, maintenance, and restoration of fiber systems. For example, loss test sets, consisting of a stabilized light source and power meter combination, are used for testing the end-to-end loss of an optical span. Optical return loss test sets measure the total amount of light reflected back toward a transmitter. Visible fault locators inject light from a visible laser or red LED into a fiber, allowing the operator to see the location of severe bends or fiber breaks. Each of these instruments has its own benefits and attributes, and each can be used to test a limited subset of the complete fiber performance characteristics. Today's ever-increasing demand for higher speeds and lower cost per transported bit has led to the requirement that fiber cable systems be tested and certified for operation at higher bit rates. Loss measurements have become more rigorous, while at the same time they are being done by less expensive equipment that are operated by people with less specific training. As fiber tolerances have improved, we've seen specifications for splice loss have decreased from 0.5 dB to 0.1 dB and less, making the measurement more difficult from a technical point of view. The demand for low splice loss is directly related to keeping transmission loss low to enable maximum bandwidth capability. The OTDR, or Optical Time Domain Reflectometer, is an instrument used to test the light transmission ability of an optical fiber cable or span, and is the only instrument that can determine both the location and magnitude of a problem. The OTDR has become the most widely used and versatile instrument for testing optical cables during installation, maintenance, and restoration. The OTDR can determine the length of a fiber, distance to events, the fiber's end-to-end loss, as well as the amount of reflected light and loss from various discrete components within the fiber. Modern OTDRs can locate and evaluate the losses of fusion splices, optical splitters, and connectors, and can even report whether each location and loss is within certain specification tolerances. Among all electronic test instruments, the OTDR is truly unique in its combination of extremely high dynamic range, rapid acquisition capabilities, and high resolution. Few other instruments used for any test application can boast over 100 dB of electrical dynamic range, together with nearly 1 GHz of bandwidth and a 10 MHz sampling rate, all in the same package. In the following sections of this DVD, we explore some of the performance attributes, applications, measurement techniques, and evaluation criteria of modern OTDRs.